What we're really trying to do is break down and figure out a way we can do business problems or solve some kind of a problem. And so we have a lot of examples in the book, but we also have some ways we can make life easier. So we started out this chapter with looking at a while loop with a preset number of items. And we said, okay, we can count to 10 or 100 or 1,000 or 1,000,000 or whatever number we wanted. Well, almost every program, though, language, has an even shorter, easier way to use it. So we can do the while loop, and internally that's still what happens, but almost every language has some form of a for loop. And a for loop says, we directly say we want to make a loop for X number of times, and it puts it all together in one little short statement for us. So that for statement initializes all your stuff, evaluates it, and increments it all in one time. So we don't have to have as many little steps in there. So it really is a way to make our life easier. So a for statement, depending on which language we're going to look at, looks like this. For whatever value we're originally going to start with, so that's that loop control variable we looked at before, for one value from a beginning to end, and then we use some kind of a step. A lot of languages just have a +1 if you want to do something. Then everything inside that body, where it says do something there, we're going to actually make happen. So however many times we're going to do it. And then that end. So we always have a beginning and an end, just like we do in web class and other ones. We have that beginning and an end so we know where it's at. We indent so we know what is executing in that block. We don't have to do it by ones. So we can add in this case we're using step, or we could say +10. You can use a negative value, so you could go down. So if you wanted to do a countdown from 10 to 1, because you're going to celebrate New Year's Eve in New York City and you're putting up the ball, here I've got that for year or time equals 10 minus 1, and we can create that loop. So this is an easy way to do a loop if I know exactly how many times I'm going to do something. So that for loop, great shortcut. Much easier to use in some cases. We have less things to think about. And the difference, though, in some cases we know how many times something's going to execute. In a lot of cases we don't, and we're waiting for some kind of external event. But when we think about that for loop, does it have to be a set hard-coded value? So if I come in and I have let me bring up Notepad here. So I could say for number of students to 0 step -1. So now I've created a loop, but I didn't hard code that because I don't know what that number of students is. It may come in from another place in my program. So this is going to count down all of my students. So I could have done it from the other way. So I could also have said from 0 to number of students. And inside this loop then I have send congratulations letter. Send final bill. Send diploma. End for. So then what this is going to do is this is going to run however many number of students we have. And so that could come out of another piece of our programming code. So it could even be up here that we've set it at number students is equal to 1,200. And so this is going to loop 1,200 times. Best practice is we come in and we use variables in here so that we can make those changes. We don't hard code them. So if I wrote this for 1 year, maybe 1,200 students is the right number. But next year that value may change, so now I can simply change that or get it programmatically elsewhere, and I can say, all right, now that number is going to change. So those for loops, we can do loops of a set number of times. So really handy if we're going to do something over and over and over again. And this is an easy way to do it. One for statement, everything inside of here and then the end. So beginning and end we always need to have so we know where it's at, and blocking. And that's one of the issues that I see when people look at this. So what else do we use loops for? And one of the things we often do is we count with a loop. We need to figure out how many times something happens. And so we count with our loop, and they call it an accumulator or something else, but we count. Every time something happens, we add one to our value. Like, well, okay, so what kind of loops could we have? So in this particular case, we're looping through to get totals. So if I look at this particular piece of code, I have my declarations. So I'm declaring string price. Here's a heading. And I output that heading 1, output heading 2, and then I'm asking for a price and an address. I get that information. We check to see if we're done. So there's some kind of sentinel value. So in other words, if they type in 999, then it ends. If they don't, we take that input and we price, and we come out here and we output it. So in other words, we put it up on the screen, or it goes to a drive, however we want to think about it. And then we say accumulated value equals accumulated value plus price. So each time this loops through, we're adding in the next price of a house. Once we get to the end, then it outputs that total of accumulated value. So it looks like this. We put in this address, 287 Acorn Street, 150,000. It loops again. Now we put in 12 Maple Avenue, and it adds 310,000 to the price. We loop again, and finally at the end we end up with a total then of, in this case, $1.1 million in sales. So we're just looping through our data. So here's our pseudocode for the same thing. So up here we say we know we have an address and we have a price. That accumulated value we set to 0. In other words, we're cleaning out that house, making sure that there's nothing stored in there from the last salesman. Here we have our first input. That input, address, and price, so that's that priming the pump input. So before we go into our loop, we have to ask that input and price. We come into our loop and we say, all right, output that address and price, so you're putting that in line. You're adding your value, and you're outputting then that address and price. Except there's a little bit of a problem with our code here. Does anybody see what it is? Correct. They have a typo in this particular slide. So where it says output, that's really input, and it's really this step right here. So they actually made a mistake when they wrote that. So in this case, if we hadn't taken another input, this would just simply loop forever. So what we're looking for is this output. So we're going to go in and we're going to grab pieces from different people. So we could do the same thing. We could do the same thing. So we're going to eliminate this, and we're going to write a program. We want to keep track of our savings. I know, college students and savings. So I want a couple of different pieces I'm going to put in here. So I'm going to have a number for savings total, because I'm going to have a value, and I'm just going to go ahead and set that equal to 0 just out of practice. And I'm going to have one called daily contribution. And so in this particular example, I'm going to create a loop, and I want to add that up every day. And so I'm going to use our friend the while loop. So I'm going to say while, and so we need some kind of a counter, some way to control this loop. So I'm just going to use while, and I'm going to use the value counter not equal to 999. So you can stop this program at any time by typing 999. So counter equals 0, so I'm going to set that to 0. And just out of habit up here, I'm going to set that one equal to 0. So when this program starts, there's no values. Everything is set to 0. And so while counter not equal to 999, that's going to let it run as long as I don't put a value in. So I need to check a value to start with. So I'm going to input daily contribution. So in other words, you're going to put in the morning what my savings for that day is. And so then down in here, so while this loop runs, I'm going to say, all right, so my saving total is equal to saving total plus that daily contribution. And because I want to remind you of what it is, so we're going to output saving total. End while. So my loop, all it does is loop through here and says, every day I'm going to put in a certain amount of savings. Unless at some point I say, you know, I'm done, and I put in 999. So there's a really quick issue with this program. What's the first issue we see? Okay. So this while loop isn't going to do anything, so I'm going to put my input. And because I can use copy and paste, and this is the only class probably where I'll ever say use copy and paste, so now that loop will actually go through several times. But I have one more problem with it. What's the problem? Does anybody see it? And that, yeah, I probably did. Oh, there's a saving one. All right, so, and daily, oh, there I did one. All right, so, but that's not the problem I'm looking at. That would cause a problem with our program, though. But what am I basing this loop on? So this loop, what is the loop control variable in here? Oh. So I have a counter variable. I put it up here. Is that counter variable ever change? So is this loop ever going to end? No. So what I really need instead of counter in here is I'm going to look at daily contribution is not equal to 999. So I have a variable up here, counter, though. So I already created a variable, so let's use it for something. And so I'm going to use it, and what I'm going to do is I'm going to say counter equals counter plus 1. And so every time this loops, it's going to add 1 to that value of counter. And so not only am I going to output the saving total, I'm going to output, and I'm just going to put it in quotes so we can see that it's something you have saved for counter days. So now it's not only going to add up my values, but it's also going to tell me how many days I have saved up. So if I have 1 day, 10 days, until I type in 999 into that daily contribution, it's going to put that out. So we would say, all right, now we saved $1. So here's what we call a desk audit. And this is putting in values, and so we can see what's going to happen. So we wrote this code, and we said, okay, so now I want to test it out. And so the first day comes and it says, input my daily contribution. So down here, I'm just going to keep kind of a running total. So the first time it runs, I'm going to put in $10. I had some extra money that day. So it's going to run, and what it's going to output then is it's going to say output saving total, so it's going to output 10. And because we already added 1 to counter, it's going to say you saved for 1 day. That's actually going to say 1 days, but we'll leave the logic alone on that. So the next day comes in, and I only had $5 extra. So it's going to loop again. And so now it's going to output that I have $15 and I saved for 2 days. And so we could keep that accumulation going as long as we wanted to. But on the third day, I went to the casino and I had no money left. And so I said, I'm done. I'm going to put in 999. Once I put in 999, does it run this loop here? It does? So let's look at our logic for something like this, which happens to be right here. So here's that same end of file. So we just did it as 999. If we reach end of file, in other words, it says we're 999, it automatically dumps out. So we actually probably need something else in our program, a couple of other pieces. So because we ended our loop, we really should then have these outputs here, because otherwise we wouldn't have any output. So I'm going to put that here and probably put out something else. As long as you did. And so now, when I did that, once I put in that 999, it's going to output my savings that I saved for 2 days, and then it's going to have my statement about thank you for saving as long as you did. So now we've made a useful little, small little program that says, here's a couple of items, we're going to look at them, now you output a variable. So we counted a number of times that we went through, and we counted how much that value is, and we used those accumulators to do both of those. So our program doesn't care how many times it goes through there. So it can go through there 1, twice, 400. So you could save every day for 10 years, and it doesn't care. Or it could save for 1 day. So we could make it fancier and do all kinds of things, but this is just a quick, easy way to look at using that loop as a way to accumulate a total. Some way we add up our values. So here we have another loop, and it's a great example of what we can use a loop for. So in this particular case, we're using a loop to check if our data is correct. So we put in data in this case, so we say, here we're asking for enter a birth month, and they're inputting a month. So we say, well, we know there's a couple things that can happen. We know that birth months are only a certain limit. We only have 12 months. So we want to see if we can control that. So here we say high month equals 12, low month equals 1. So we have a set of numbers in there. So enter your birth month. They put in a value, and then we check. So if the month is less than low month, so if somebody put negative 151, or the month is greater than high month, then that's going to be a value where we have to come in here and say yes, enter the month again. So in other words, it's going to ask them for that prompt again because we didn't do it correctly the first time. They didn't put in the right value. Maybe they put in May and go, well, that doesn't fit our values either, and it's going to go through and we're going to ask them again. But the problem with this is, how many times can they screw up if I look at this code? As many times? We'll take a look at it again, because that's not a loop. It's only one selection. So we've asked that question once, and so we have that issue of, oh. And I know nobody in here would ever screw up more than one time, but if you've ever been somewhere and you watch people put stuff in the computer, for example, and they're trying to get through even an ATM, you'll see people that'll make mistakes 3 and 4 and 5 times. Well, we know that people get very easily confused. For one thing, we really don't explain this very well. We don't say enter your birth month by using a number from 1 to 12. So here, if we ran this code, it's going to only run once, and so we hope that the second time they do that correctly. But what we can do is we could make that a loop. So very similar structure, but now we are asking, so instead of just having a selection there, we're saying while that month is less than low month or month is greater than high month. So while it's outside of those parameters we want, then they're going to have to input another month. It gets checked again, checked again. So this, somebody could screw up 1,000,000 times on there, and it would still not exit that loop because you're asking that user for an input and you're validating it. And so we validate a lot of times using these because we don't know what people will do. Anytime you think you understand what people are going to do, human stupidity will actually save you a little bit. So this is a way we can validate data. So we can put that in a loop. It goes continuously through there. We check over and over again. So if I look at the pseudocode, it's really a pretty simple piece. The hardest thing people have to do on this is remembering that you have to repeat this priming action inside the loop. Because if I don't put anything in here, that loop's not going to do anything. Logically, it makes sense if I could just think I could just come up here and go yes and come back up to the top of this loop, but we can't. We have to go back to the top of the loop. So it's an easy way we can validate loops or validate our data. So we can control a loop. We can do a while loop for either a set number of times. We can do a while loop for an unlimited number of times using some kind of a value that escapes us out of that loop. But the hardest part is we have issues with loops. So if we don't initialize that loop variable, so in other words, resetting it to 0, because we use that all the time in our program. So we may use the same loop control variable many times. So if I do a for loop and I use x as my variable in there, I may find x is used 100 times in my program in other places. So I always want to make sure I initialize that loop variable. I don't make any changes to it. In other words, I end up in that infinite loop. Or I put stuff that's in the wrong spot. So loops are great. We have that for loop, and that's kind of our shortcut because it gets all the pieces in there together. We can use them to count things. So if I had a simple example of I was writing software for a door. And that door, so we have a door, and every time that door opens, so here we would need a door counter equals door . So we know that we want to have this statement in there. So every time that door opens, we increase that value. So we would probably write it as a while loop. So while some condition is true. So we could say while power equals on. So we could even do something like this. So as long as the power's on, we're going to keep track of that. And then we're going to output that to somewhere. Output door counter. And then we have our end of our loop. So that one's really simple. All we're doing is every time somebody opens a door, we're adding 1 to that. So that accumulator, this idea of putting whatever's in my value plus some number back into my original value, that accumulator, is an important concept we use a lot. And we could do it with 3 or 4 or 5 different variables, but we can use the same variable. So what we're doing is every time somebody opens the door, here we cycle and we add an additional count. So the easiest thing I think to start on, so let's look at, in the back of our book, on some of the problems, and we can actually look at some of these. And some of these are actually your homework assignments, so we might look at a couple of these. So let's look at number 7 out of the back of your book. So in the following pseudocode, what is output if A equals 1, B equals 2, and C equals 5? So the easiest way I've always found to do these is to actually put it into something like Notepad or scribble it down on a sheet of paper, which you wouldn't be able to see, and I actually take that problem. So luckily, our friend copy and paste. So I can actually copy that in there. And now I can say, so if A equals 1, so I'm going to put those up here so I know what they are. So A equals 1, B equals 2, and C equals 5. So this is that desk audit or desk running of my code. So while A is less than C, so in other words, while 1 is less than 5, well, we hope that that's true, right? So A is equal to A plus 1. So in other words, we're going to do a count. So this then very quickly, so what you're really saying is A is equal to 1 plus 1. So in this case now A is now equal to 2. And now we're going to look at the next line where you're going to say B is equal to B plus C. So B is equal to 2 plus 5, or B is now equal to 7, end while. So what we have to think about in here then, and we're going to output A, B, and C eventually. But is this loop done running? So we now have A is equal to 2, B is equal to 7. Have we changed C at all? C is still equal to 5. So now we need to run that loop again. So now A isn't a value of 1 up here anymore. A is now equal to 2. Is 2 still less than 5? So now we come down here and we're going to add 1 to the value of A. So A is now 3. B now, B was 7. But what we're really saying is 7 plus C. So 7 plus 5 is 12. C doesn't change. So we're going to loop back up to the top again. So now is 3 less than 5? So it's going to loop again. So A becomes 4. B then says B plus C. So 12 plus 5. So B then jumps to 17. C doesn't change, and we loop again. So now we have 4 is less than 5. Is that still true? So we loop once again. So we go A equals A plus 1. So now A is going to change to 5. B is going to change to, we're going to add 17 plus another 5. So hopefully that's 22. And we're going to go down to the end of our loop, and we're going to come back up again. Well, now we're saying, is 5 less than 5? That's false, isn't it? So when we have that false, do we run these statements? We jump out of our loop and we output A, B, and C. And so now we output 5, 22, and 5. Does that make sense? So all we're doing is desk auditing these to see if that makes sense. And is there an example on our solutions that matches that? Oh. So, quite frankly, we could have shortcutted that just a little bit. If I have the solutions here, I know that as soon as, when I look at this, I know that as soon as A is 5, that's going to trip out. I know it's not going to hit 6. So I know it's either B or C. All right, so let's do the same thing with number 8 and see if we can come up with a solution. So in this case we have, while D is less than F, we get the variables down, D equals 4, E equals 6, F equals 7. All right, so now we know that this is going to loop. When I just look at this, so we already know that D is equal to 4, so we're saying 4 is less than F, which is 7. So just from that, looking at the very top of that, can you guess which one it's going to be? So we're asking for, this loop will run until, as long as D is greater than F. So while D is greater than F. So let's look at that. So if I put this in there and I say while 4 is greater than 7, so what does that evaluate right there? It evaluates as false, doesn't it? So we know that that's going to evaluate as false. Does any of this code in here run? So what are my output values? So when I output D, E, and F, have they changed at all? So what that one is going to tell us when we look at it, it's actually going to be, and what a lot of people do when they look at it is they look at that, and we're so used to doing the less than, they don't even notice that that's a greater than symbol. So let's look at number 12, kind of a similar structure. But now we're having it output something. And what we're doing is we want to count how many times hello gets output. So while J is less than K, so while 2 is less than 5, and while M is less than N, M and N, output hello, M equals M plus 1. This inside loop ends, and then we have J equals J plus 1. So that's that nested loops. So we have an inside loop. So that's our seconds, if we think back to that example. And this is our minutes. So we have a set of loops. And so now we need to figure out what's going to happen. So here we need to put in some values and kind of see where we start. So I'm going to copy this and paste it into our friend Notepad. And then I'm going to say, all right, so I have a set of values. So I have J, K, M, N. And so those set out equals 6 equals 9. So when we first run this program, those are what those values are at. So we can substitute them in, and so you can look at them. So K is equal to 5. M is equal to 6. Is less than 9. So output hello. M equals M plus 1. End while. And then we have our J equals J plus 1. So let's see what happens when we first go through this initial loop. So we know that that value is 6, so we could put that in there. And we know that that value is 5. If we want to plug in some values. So when this loop first runs, is this outside loop initially true? So is 2 less than 5? Yeah. All right. And then we go to our inside loop. Is this condition true? Is 6 less than 9? Yeah. So it's going to output a hello. So maybe down here we're just going to keep a running tally. So we say it doesn't hello once. It comes down here, and now M is no longer 6. M gets jumped up to 7, right? So M is now going to be 7. And it's going to repeat this inside loop. So now you're saying, well, 7 is less than 9. We don't go out to this outside loop. We're just inside this loop here. So is 7 less than 9? Yep. So it's going to output a hello again. So I'm going to put another one down there. So it's going to output hello twice now. And it's going to say M equals M plus 1. So M is now going to go to the value of 8. And so we could say, well, is 8 less than 9? Well, that seems true. So we're going to say hello. And we're going to say hello one more time. So now we come down here, and now we have a value of 9. So our loop comes back up here, and so we say 9 is less than 9. Is that true? False. So now what happens? Our loop ends. So our loop comes down here, and so we get an extra J. So J now is going to equal not our initial value of 2. There it is. Sorry, 2 plus 1. It's going to equal 3 now, right? So 3 is going to come up here. Is 3 less than 2 or less than 5? Is that still true? But look here. So while 9 is less than 9, is that false? Because we didn't change that value back. We didn't reset our loop counter. So this isn't going to run. It just exits back out to down here. So now we say J equals 4. So is 4 less than 5? Yep. So it tries to go, but this loop, inside loop, doesn't run. We come back down here. Now we set J equal to 5. Is 5 less than 5? No. Comes and ends that entire loop. How many times did we output hello? We only did it 3 times, didn't we? Because we never reset that value up here. So if I looked at this code and I said, I want to fix that, how could I fix that? So let me get the original code, because I have changed some of those values. So what happens in here is we don't ever reset any of these values. We add m. So this loop here, if I want to look at it and break it out to make it a little easier to see, this loop here, once it runs through its setup, it never resets, does it? So the way we could have done that, if we wanted it to print out, so like our clock, we wanted it to reset. Because if we had this as a clock, what would happen is it would run through the seconds once, and then it would just spin through the minutes, because we don't have any way to reset it. So we would need some value in here. So we could actually say then m equals, if we originally wanted it to set it to that 6, if that for some reason is a value we wanted, so we would then have that also equal. So we would reset that loop. If we did it this way, if I change that as simply as saying m equals 6, which is our inside loop control variable, now this would print out 9 times. Because this one, when you look at it, when you first think, well, the outside loop runs 3 times. The inside loop runs 3 times. I multiply those, and I have 9 times. And so if you first glance at it, that's what you would run into. You would say, all right, 9 times. But because we know that that inside loop here doesn't ever reset, they left out a statement to reset that loop control variable, it's only going to run 3 times. Now, we don't have a lot of information. This is just a piece of code. There may be a reason they wanted to do that. But that is an example of them forgetting to put in a loop control variable. So here we have one very similar. So number 14 is similar. So it says, while p equals 2 and q equals 4, how many times are you going to print out adios? So here, notice they actually do reset r equals 1, which is that control variable for the inside loop. So in this case, r is less than q. So value of r is 1, and then q is 2. So this is going to run how many times on the inside? So we have 1 less than 2. So it's going to run once. It's going to come up to the top. Is it going to get a run a second time? So if I look at just this piece, here. So we know that r is equal to 1 to start with. So at the beginning of this, r equals 1, and q, so the value of q starts out at 4, right? And so q equals 4. So we know it's going to run once. So it's going to say, have that value of is 1 less than 4. So we know adios is going to get printed once, right? So in fact, we should be able to tell how many times that's going to print right now. So if I have initial values of 1 and 4, and I know I'm going to go up by 1, so the first time it's equal to 1, second time it's 2, so now we have another print. We add 1 more, so it's going to be 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3. 3.
Is it going to print a fourth time, though? So when we go to 4, it's going to say 4 less than 4. It's not going to print on the inside. Okay. So we know inside loop is going to run 3 times. Well, I can also look at that, and I can figure that out. Notice that I know what my initial value and my ending value is, and I minus 1, and magically that gave me that 3. So I know that 3 times that's going to run. My outside loop, so let's go look at the whole code then. So I'm going to grab, if it'll let me. So I have the whole code now. And so I know the inside piece works. I know that that's going to run 3 times. Every time this outside loop runs, the inside loop here is going to run 3 times. I know that, and I've got a reset in there, so it resets it. So we're not going to have the same issue. So while P is less than Q, so in other words, while P, which is 2, is less than Q, which is 4, this loop's going to run. And so I know that outside loop's going to run once, and that's going to change that to 3 less than 4. So that second loop is going to run once again. I know that's going to run. But is it going to run a third time? So it's 4 less than 4. So the outside loop is going to run twice. The inside loop, every time it runs, outputs 3 adioses. So what I'm doing is, every time this outside loop runs, I get 3 adioses. When the outside loop runs, it runs the inside piece once. So 2 times 3 should be 6 times this statement in here runs. All right. So some of these exercises, so your homework assignment for this week, there's a debugging piece. We can get back there. So here's a program, and it has an issue or two. So those multiple choice questions, and we went through several of them. There is this single debugging program. So in this particular case, we're printing out a mailer of some kind, so we need to figure out what the issues are with this program. Well, one of the ways to do that is start to look at, how do I create some of these simple programs. So here it says, design the logic for a program that outputs every number from 1 through 10. Well, we want a number, so we're going to say num number, set it to 0, and I want to output, so I know I'm going to have an output number, and then I need to count somehow. And so I can do that with a loop. So I know that I could do a loop like, so while number is less than 10, interesting. So now I'm saying, while number is less than 10, I'm going to output. But what is that going to output if I run this loop right now? So I'm going to end while. So I'm going to output a number. And I know that I'm going to have to do number equals number plus 1, so that I'm adding in a value. So that's going to output how many numbers? It is going to output 10 numbers, but what's it going to do when it runs? So I can run this through in my head. So number equals 0. While number is less than 10, this loop's going to run, so these pieces are going to run. So it outputs a number. So the first time this runs through, what value am I going to get out? What's number equal to the first time this runs through? So let's go through that again. So up here we set it to 0. We start our while loop. So while number is less than 10. So what's its value right now? So that is true. 0 is less than 10, so it's going to run. I'm going to output number. Oh. So I'm going to output 0. Okay. So 0. So 0 plus 1 is 1. And it's going to go back up here and say 1 is less than 10. So is there an easy way to fix this so it outputs the right number for me? Well, there's a whole lot of them, but the easiest one in this particular case, what if I just did this? What if I changed that order that I did this in? What's going to get output now? So at the beginning, so 0, numbers equals 0, first loop through, number equals number plus 1, output number, and it's going to output 1. Oh. Okay. Well, maybe we're on to something there. So as this loops through, we're going to get to, let's look at number 9. Let's see what happens. So we've printed 1 through 9. So now this value is number 9. So is 9 less than 10? So number equals number plus 1. So now number is equal to 10. Output the number. So it printed 10. It loops back up here. Is 10 less than 10? No. And it dumps out. So there are a whole lot of ways we could have done the same thing. So just by changing that order and thinking through how that works, we could have said number equals 1, and while number is less than 11, you see how we get that logic, and then we output the number. But in this case, we would want to start it the other direction. So we'd want to put that here. Is there an even easier way to do it? What's the shortcut we talked about in this chapter? If I know how many times I want to loop something, what if instead of all this, I just said for number equals 1 to 10, step 1, output number. So our for statement gives us a really quick way we can do that. We can say, here's our value. So is that simpler? Yeah. So especially when we get something really bizarre. Now, it doesn't work for all cases. I have to know ahead of time how many times it's going to loop. So a definitive loop, it works really well for. So if I look at that and I go to problem 2, I think it is, design the logic for a program that outputs every number from 1 through 10 along with its square and cube. Oh. Well, all right. So now we took our original program. Does this output the number? Yeah. And could we set up a variable called, let's call one cube, and let's call one square. And so we're just going to say those, we're going to set them both equal to 0 to start with. So now, let's think about what is a square? So it's a square, so we could actually just say square equals, and so we don't know about the functions yet and what kind of things it are, but we could say number times number. We could do it the old-fashioned way. And we could say cube then equals number times number times number. Or we could probably say number cubed. We could do it a variety of different ways. So however it happens to make sense to you. And then we output cube and we output square. So same logic, it doesn't change a whole lot. But now, let's say I wanted to do this, and I want to output every number from 1 to 50. Well, here we go. I changed one value, and I can do that. What if I want to output only the even numbers? I can rewrite that for statement for number equals 2 to 50, step 2, step plus 2. So now I've modified it, and now we're going to output only those values that are even. So we're going to go 2, 4, 6, 8, and it's going to do all those pieces to it. If I want to count down, so I want to look at 50 to 1, I can do the same thing. So I could say 50 to 1, and now I just have to say I want to decrease it, so step minus 1. If I wanted to do it by tens, I could do it step minus 10, and each time it's going to decrease that value in number by 10. So those for loops are a really handy item when we start creating really simple programs like this. So if I wanted to do number 4, design the logic for a program that outputs numbers in reverse order from 10 down to 1. Well, I could do the while loop, but now that I know I can use this for loop, I'm going to get rid of all this other stuff because we don't need cubes or anything else. So for number equals 10 to 1, step minus 1. And that's all we would have to do. We initialized our loop, we control our loop, and we count all the way through in our for loop. So those for loops are a really, really great way to look at things. All right, so our homework also has this debug thing. And so the easiest way, I'm going to grab it and take a look at it inside of Notepad so we can look at it a little bigger. Now, I will say this, in our Blackboard, it tends to screw up our indenting. So let me fix this really quickly so it looks a little easier to deal with. Oops. One more over. So this one would be that. All right, so now we've rearranged those indenting so that makes sense. So we need to keep those. So here's my inside loop. Here's the outside loop, and you want their beginning and their ends to allow to work at the same thing. So what this program is doing is it's going to print 360 payment coupons. So if you buy a house, you get this giant book of stuff that says, all right, for the next 30 years, although if you're buying a house, don't ever do it for 30 years, but they'll sell you one that says 30 years you're going to pay on this house. So it's going to print 360 monthly payment coupons for you. So each coupon is going to list the month number, the year number, and a friendly mailing reminder. So we can put a couple of things in here. We know that they're already in there. So we declare a variable called months and years. And we capitalize those because in general, we know that those are what we call a constant. Something that's not going to change in the program. And so generically, we tend to capitalize those, and it gives us an idea that this value we're not going to change, but we want to use it as a variable anyway. Maybe, Trump will decide that we need 13 months in a year. Who knows? So we have those values of 12 months and 30 years. And then we have this message that says, remember to allow 5 days for mailing. And then we set a couple of those counters equal to 0. So we have a month counter and we have a year counter. So our inside loop is going to be dealing with months, and our outside counter is going to be dealing with years. So we have just shifted our clock example. Now we've shifted it into months and years. So this inside loop, while month counter is less than months, output month counter and the year counter. So you're going to output the month and the year and your message, this remember to allow 5 days for mailing. It's then going to add 1 to the month counter, and then it's going to loop again. Is there anything wrong with that when we look at it? Does anything seem wrong when we look at that month counter? So add before you output so that it outputs the month. That's one way to look at it. So in other words, what you're saying is, right now it's going to come in with the value of 0, and it's going to output month counter, so it's going to have 1 through... So right, so the first time through here, month is going to be equal to 0, and so it's going to output. So there's a couple of easy ways to do it. You're saying, because right now it's going to print out the months 0 through 11, and we know that that's 1 off from what we really want. So the easy solution would be to just flip those two. Well, hold on. Just hang on. Let's see if that. So, no, the 12 month, that would be December. So what you're saying is you're printing out a statement for month 0, which is really January, but we all know it as month 1. So it's kind of that difference between the way the computer counts and the way we count. So we need to fix that so that it outputs the... Because if you get one that said, hey, for 0 month and year 2018, you would be confused, probably. Okay. So what we're trying to do is flip that around. So there's a lot of different ways to do it. So we can flip these around, and that makes some sense to do it that way. We could also very easily just do this. So we could say +1. Output month counter +1. In other words, you're adding in a value of 1. We could come up here and we could start that month counter at 1. And in fact, the way they've wrote this, that makes more sense than anything else, and I'll show you why. So what they have is while month counter is less than or equal to months. So if they would have had that as a less than, then we would have had to do our little trickery. But because they said less than or equal, let's think what happens. So we come in at the beginning, so now we change this month counter to begin at 1. And so we come in here and we come into this. So it says, well, 1 is less than month, so 1 is less than 12. And output 1, so January, year counter and message. So that actually works. We add 1. Let's see what happens when we get to 12. So when months are equal to 12, so we've added our 11th month, we add 12. Is 12 less than or equal to 12? It is still true. So it would output month 12, and it would try to add it in, so month counter would jump to 13. It would come to the top of this loop, And is 13 less than or equal to months? No. And so it would exit out to our outside loop. So we can fix that one, and we could fix that one pretty easily. So we change that. So now we have some way to figure out the months correctly. And it was pretty simple. We just had this month counter, and we set it to 1. Is there anything else with the months that's going to be a problem? Oh, we don't have any way to reset it, do we? So we need to reset this at some way. So the easiest way, or the way I would think might be a way to do it, is at the top of this while loop. So we're inside the outside loop, and at the very top of this loop, we simply put in, then we have this line here of month counter. So now, in this outside loop runs, it first sets it to 1, loops through and increments it, and then at the end of that loop, it's ready to go to the outside loop and reset that. So we could put it at the end, we could put it at the beginning. Doesn't make much difference there. So now our months seem like they're going to be correct. Any other problems with the months? No, because remember, our loops can only go to the top. So when this loop here, this inside piece comes up, it goes only back up to here. It does not reset up any higher. This is inside that outside loop. So that's why that indenting comes in handy. Because all of these things run on the outside loop. These are the things that run on the inside loop. So that's one of the differences there. So we've got the inside loop. I think it looks fairly decent. Is there anything else we can see on there? Any weird typos? Anything else? Looks okay. So the program's fixed, right? Oh. Are there other problems? Oh. So our counter up here is set to 30 years? Oh my. So they're going to only have to pay 1 year on that loan. That would be kind of sad. So we set that to 1. Is there any other issues with this? So while year counter is less than years, so while 1 is less than the number of years, 30, this outside piece is going to run. Oh, we don't have any increment on the year counter, so this would run continually, spitting out the month of 1, right, or the year of 1. So somewhere in here we need to increment then that year counter. So you need that year counter equals year counter plus 1. So now, apparently I can't spell year either. So now, as that outside loop runs, it's going to increase this every year. Now, could we actually set it up with the actual year? We could. How could we do that? So you would want to start the year as year started. So if I wanted to change this to actually do the years, so you're saying, so year counter, so we would want to change that to 2017, right? Or 8. Gosh, I'm a year off. So 2018. Okay? So let's think what's going to happen though. So when this first runs through 2018, well, year counter, so 2018 is less than or equal to years. But we set our years up here to So you'd have to change this one to equal 30 plus 2018 or whatever it is, whatever that value is. And then that would actually work. You could spit out the actual year on every statement. And in fact, we probably would. So there's other ways you could do it, but that's a pretty quick, easy way to do that if you wanted to. Because you might get confused. You're like, I'm in year 37 of my loan. How did this happen? So that's your debugging. I would look through carefully, make sure there's nothing else that, because those simple things are going to be the ones that hiccup. When we write code, things like if I wrote months with a U instead of an O, just simple typos, it's not going to be able to recognize where you're at. All right. So your homework this week then, make sure you look at it. We did several of them, including most of the debugging, so make sure you've cleaned that up. When you turn this in, please use either a text editor of some sort or Notepad. Word at some point is going to become a problem for you, but when you turn it in as a file instead of copying and pasting it in the text box, because then the text box, it smooshes all that formatting off to the left. So if what you're fixing is the formatting, it doesn't work very well to do that. All right, so next week we start looking at a really interesting topic called arrays, which in other words, all they are is a set of buckets and where we're going to put data. So if you haven't installed Python, you might want to go ahead and get that done so you have it ready to go for us. And we're going to start dripping in little pieces of actually in the code and showing you how to work with Python in that environment. So let me delete that.